Hello and welcome to our final video notes lesson for 8.4. Today's objective will be to solve problems involving angles of elevation and angles of depression. Before we get into this lesson and talking about what angles of elevation and depression are, let's take a look at the following warm-up. Number one, we want to identify the pairs of alternate interior angles, and there are two different pairs, so I'll let you come up with that. Number two, you need to solve this equation for x, round to the nearest hundredth. And number three, using our calculator, find the tangent of 30 to the nearest hundredth. These are all things we're going to need in this lesson, so take a few moments to complete the warm-up. When you are ready to continue, push play. Alright, if you need any more time, pause the video. Otherwise, we will continue with the answers. The pairs of alternate interior angles include 2 and 7 are alternate interior angles, and 3 and 6 are alternate interior angles. When we solve this equation for x, multiply by x on both sides, then divide by tangent of 54 degrees, it's about 1,816.36. And then lastly, just using your calculator, the tangent of 30 is about 0.58. Today's vocabulary include angle of elevation and angle of depression. An angle of elevation is an angle formed by a horizontal line and a line of sight to a point above that horizontal line. So angle 1 is an angle of elevation from the tower to the plane. An angle of depression is the angle formed by a horizontal line and a line of sight to a point below that line. That's why we use the word depression. It means to sink below. So angle 2 is an angle of depression from the plane to the tower. Since horizontal lines are parallel, angle 1 and angle 2 are congruent by the alternate interior angles theorem. Therefore, the angle of elevation from one point is congruent to the angle of depression from the other point. That's your blank in your notes, the word congruent in that part of your notes. So let's take a look at example 1, determining whether we have angles of elevation or angles of depression. So we should classify angle 1 as either an angle of elevation or an angle of depression. Angle 1 is formed by this horizontal line and this line of sight from the top of the tree. Imagine a little bird looking out of the top of the tree down at this person. The person is below this horizontal line, so angle 1 is an angle of depression. Angle 1 is an angle of depression. This is what you need to write, angle of depression. Let's take a look at B. They talk about angle 4. Well, our horizontal line is running with the ground here, and the angle 4 is created by this horizontal line and this line of sight from the base of the tree. Imagine a little frog down at the base of the tree looking up at this person. So that person is above the horizontal line, so angle 4 is an angle of elevation. Angle 4 is formed by a horizontal line and a line of sight to a point above that line, so it's an angle of elevation. This last sentence is the main thing you need to write. So why don't you try parts C and D and see if you can identify the angles as elevation angles or depression angles. Alright, if you are ready to continue, let's look at what we should get. Angle 2 is formed by this horizontal line and a line of sight to the top of the tree, which is above that horizontal, so angle 2 is an angle of elevation. Angle 3 is formed by the same horizontal, but a line of sight to a point below that horizontal, so it's an angle of depression. Let's move on to example 2. And in this example, we are going to use angles of elevation and angles of depression to construct triangles to find measures using our processes for solving right triangles. So in example 2, we're talking about the Seattle Space Needle. It casts a 67-meter shadow. If the angle of elevation from the tip of that shadow to the top of the Space Needle is 70 degrees, how tall is the Space Needle? Round to the nearest meter. So we need to draw our sketch like this and fill it in as I've filled in here. We can label A as the tip of the shadow, B represents the top of the Space Needle, and Y is going to represent the height of that Space Needle. And we have our 70-degree angle of elevation. That angle is formed by the horizontal along the ground and our line of sight from the ground at the tip of the shadow up to the top of the Space Needle. So using this triangle, we can find the value of y using our trig ratios. since I'm using the adjacent leg to find the opposite leg, we're going to use the tangent ratio. The tangent of 70 degrees equals the opposite leg y over the adjacent leg 67. Remember, we solved this by multiplying both sides by 67. So y is 67 times the tangent of 70, and with our calculator we discover that y is approximately 184 meters. So the height of the Space Needle in meters is about 184. So let's take a look at our next example, example 3. We have a situation where we have an ice climber that stands at the edge of a crevice that is 115 feet wide. The angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. How deep is the crevice at this point, round to the nearest foot? Well, you have this diagram already drawn for you. Let's take a look at what it would look like. We're going to draw our sketch and label it a little more in depth. We're going to let C represent the ice climber, and B represent the bottom of the opposite side of the crevice. We're going to let Y represent the depth of the crevice. Well, we know the crevice is 115 feet wide, and we know this angle of depression is 52 degrees. Well, by the alternate interior angles theorem, angle B would also be 52 degrees. The bottom of the crevice is parallel to this line of sight across this horizontal line across the top. So this 52 degree angle would be the same as this 52 degree angle because they're alternate interior angles. So if this is 52, we're looking for y, which is opposite that 52 degree angle at B, using the adjacent segment, BA. So I'm using adjacent to find opposite. I'm going to write the tangent ratio. The tangent of 52 degrees, remember angle B is also 52, would equal y over 115. So once again, solve this by multiplying both sides by 115. And when you've done that, go ahead and check your answer. I'll give you a little bit of time. If you need to pause the video, go ahead, and then we'll check our answers in a moment. All right, we should be ready to continue. When you multiply both sides by 115 times the tangent of 52, we should get that the depth of that crevice is about 147 feet. All right, let's take a look at our final example in this video, example 4. We have an observer in a lighthouse that is 69 feet above the water. He sights two boats in the water directly in front of him. The angle of depression to the nearest boat is 48 degrees. The angle of depression to the other boat is 22 degrees. What is the distance between the two boats, round to the nearest foot? So we need to draw a sketch of this to match with the pictures that I've given you. So what I want you to do is kind of follow along with the sketch I draw, and just write directly over top of what you have. We're going to draw our sketch like this. We're going to let L, you can kind of see it there. I'm going to move these shapes out of the way in a second. You can see L is the observer in the lighthouse. And so we've got a horizontal line stretching out from his observation point to M. And he's 69 feet above the edge of the water. And we're going to let A and B represent the two different boats. There's A and there's B. So remember, the angle of depression to the furthest boat is 22 degrees. The angle of depression to the nearest boat, this arc, is 48 degrees. Okay, so let me move those out of the way. So we have this set up. We should have this figure drawn. This is our 22 degree angle of depression to B. This is our 48 degree angle of depression to A. And because of alternate interior angles theorem, angle LAC is 48 degrees and angle LBC is 22 degrees. And so these create two different triangles that we can use to find Y and Z. And once we find Y and Z, we can subtract this measurement from the total Z to find what X is, the distance between those two boats. So first, let's find Y. We're going to focus on this triangle, LCA. By the alternate interior angles theorem, the measure of angle CAL is 48 degrees as well. And so to find Y, that's the adjacent leg to 48 degrees, we're going to use the opposite leg 69 feet to write this equation. The tangent of 48, because it's opposite over adjacent that we're using, equals 69 over Y. We need to solve this equation for Y by multiplying both sides by Y first, and then dividing by the tangent of 48. We should get that Y equals 69 over the tangent of 48 degrees, which is about 62.1 feet. So go ahead and write 62.1 feet where this y is. And now we need to find z. Now z is the full length from C out here to B, the second boat. So in order to find z, we're going to look at this triangle, which we're using this 22-degree angle, looking for z, the adjacent leg to that 22-degree angle, using the opposite leg 69 again. Remember, we know this is 22 degrees by the alternate interior angles theorem. It's the same as that angle of depression. So I can set up this equation. The tangent of 22 equals 69 over z. Once again, to solve this for z, you first multiply both sides by z. So z tangent of 22 would equal 69. And then divide both sides by tangent of 22. So z is 69 divided by the tangent of 22, which is about 170.8 feet. I'll let you take a minute or two to get caught up with this if you need more time. Alright, so we found that z is 170.8 feet. And if you go back to what we found for y was 62.1 feet. So to find x, we're going to simply take y and subtract it from z to get x. X is z minus y. So 170.8 minus 62.1 is about 109 feet. The distance between the two boats is 109 feet. Alright, that wraps up example 4, and you'll notice we still have 4 more examples in lesson 8.4. We are going to cover those in class on block day. So unless you have any other questions, we will talk about all this again on block day and begin that assignment in class.